Hello, this is Scholar Strife doing some math today in Algebra 2. We're going to be looking at exponential models. So probably before you've already learned about graphing. Now we're going to use them in some application here. So let's look at the exponential growth model. When a real life quantity increases by a fixed percent each year, the amount y is modeled by this, where a is your initial amount, r is your growth rate, t is time, and 1 plus r is your growth factor. So we like to use this usually in population growth, bacterial growth, appreciation of goods. So like a certain car appreciates over time, which means it's worth more over time. Usually when you buy a car, it depreciates, but we'll get down to the decay part of this. But here we go. Let's do an example here. Number 1 in 1970, the population of Kern County, California, where Bakersfield is located, was about 330,000 people. From 1970 to 2000, so 30 years, the country population grew at an average annual rate of about 2.4%, right? An exponential growth model giving the population y of Kern County 2 years after 1970. Okay, and then approximate how many were in the year 1990. So our formula here is, so y equals, let's follow this, a, our initial amount is 330,000 in 1970, and then 1 plus our rate of growth is 2.4%. Now be careful, we don't use 2.4, but we use the decimal. So this is going to be 0.024 as a decimal. That means 2.4%. So 1 plus 0.024 to the t, which t in this case, well, actually they just want us to write formula here. So 330,000, 1 plus 0.024. Okay. Now they want us to know, so that's our formula. So now they want to know how many people lived in Kern County in 1990. So we're going to use the formula, 330,000 times 1.024 to the 1990 is 20 years after 1970. Plug this into your handy dandy calculator and get 530,290 people. Graph the model using a graphing calculator and estimate the year in which the population of Kern County was about 400,000 people. So if you have a graphing calculator and you know how to graph, so basically you'll get a graph that looks something like this, and you use your trace function to find out when it was 400,000 people, and in this case t is around 8. So I didn't go heavily into this, but if you know how to use a graphing calculator, you should be able to find it. Have your x window be 0 through 25, and your y value window be 600,000. So t is about 8, so 1978, there was 400,000, or probably there was 400,000 people. 2, rabbits. So whenever you think of exponential growth, you want to think of rabbits. Usually rabbits. Population beginning with 25 rabbits doubles twice a year. How many rabbits will there be in 3 years? So we have an initial amount of 25. Our R means double, so 100% or 1.0. So it doubles twice a year, so T is not going to be 3, but 3 times 2, because it does it twice a year, so 6. So our formula is y equals our original amount of 25 bunnies. They double twice a year. And we do it on for 3 years. That is 1,600 rabbits. That's crazy. Rabbits. Alright. Now let's look at exponential decay. So same thing. Initial amount. This time it's the decay rate. Time is still time. And 1 minus r is now called the decay factor. And this is usually in depreciation. Also population. So a new snow machine costs $4,200. The value of a snow machine decreases by 10% each year. Write an exponential decay model, and then estimate snow machine after 3 years. So y equals 4,200, my initial amount, minus 10%, which is 0.10. So remember, this 10% becomes 0.10 as a decimal. And then t. And then we put in t equals 3 into the equation, and we'll get y is about 3,661.80. So it used to cost $4,200, now it only costs $3,061 after 3 years. That's not actually that bad, especially with all the usage, most likely, and but yeah, graph the model using graphing calculator, blah blah blah. This will give you 4.9 years if you've done it correctly. Now, once again, I'm not going through the graphing calculator problems. I will do them in class. If you need help using graphing calculator, I'll do a video on that later. A new car costs $32,000. The value of a car decreases by 15% each year. Write an exponential decay model and then estimate the car after 4 years. So this will be y equals 32,000. 1 plus 0.05. I mean minus. Minus, this is decay. So your equation, y equals 32,000 times 0.85 to the 4 years. And that'll be 16,704.20. So it might be around 16,000. So you lose. For 4 years, it's down to half. And I believe that is all I have for you today. Have a good one.